Rational Functions Part 2. Follow the 7-step strategy to graph the rational function. Here I have a rational function, and the first step is determine symmetry of the graph. I'm going to test for y-axis symmetry and origin symmetry. For y-axis symmetry, f of negative x should equal f of x. First, we'll find f of negative x. That means I'll plug in a negative x wherever I see an x in the original problem. So I have negative 7x divided by negative x minus 3. I can factor out a negative from the denominator, and I get negative times x plus 3, and for the numerator, I still have that negative 7x. Lastly, a negative divided by a negative is a positive, so this simplifies to 7x divided by x plus 3. So f of negative x is 7x over x plus 3. Now if we compare that expression to my original expression, I can see that these are different because the denominators are different. That means that I do not have y-axis symmetry. Now I'm going to test for origin symmetry. The graph is symmetric about the origin if f of negative x equals negative f of x. I already found f of negative x, so I'm going to find negative f of x. That means I'm just going to apply a negative sign to the original expression, which is 7x over x minus 3. Now this is completely simplified. Negative f of x equals the negative 7x divided by x minus 3. If I compare these two functions, they are not equal. So I do not have origin symmetry, and my answer is neither y-axis symmetry nor origin symmetry. The second step asks me to find the y-intercept. To do that, I'm going to find f of 0. So I'll plug a 0 wherever there's an x in the original function, and I get 7 times 0, which is 0, divided by 0 minus 3, which is negative 3, and 0 divided by negative 3 is 0. So my y-intercept is 0. Now I'm going to find the x-intercepts. To do that, we're going to set the function equal to 0 and solve for x. So I'm going to multiply both sides by the denominator, x minus 3. The denominators cancel on the left, leaving me with 7x equals 0 times x minus 3, which is just 0. And then I'll divide both sides by 7, and I get x equals 0. So my x-intercept is 0. Now I'll find the vertical asymptotes. To find the asymptotes, first factor the numerator and denominator. The numerator and denominator of our function are already factored. Then we'll look to see if we can cancel any factors, and we cannot. So, since we can't cancel any factors, I'm going to just take the denominator and set it equal to 0 and solve for x. So I'll add 3 to both sides, and I get x equals 3. And this is the line of the vertical asymptote. Now I want to find the horizontal asymptote. To do that, I'm going to look at the degree of the numerator and the degree of the denominator. The degree of the numerator is 1 because that's the highest exponent, and the degree of the denominator is also 1. Since these degrees are equal, I can find my horizontal asymptote by dividing the leading coefficient of the numerator by the leading coefficient of the denominator. So the leading coefficient of the numerator is the value next to the x, which is 7, and I'll divide that by the leading coefficient of the denominator, which is a 1. So I have a horizontal asymptote at 7 divided by 1, which is 7. And that means that my line is y equals 7. Plot points between and beyond each x-intercept and vertical asymptote. find the value of the function at the given value of x. So MyMathLab is going to have you evaluate the function at specific x values. So we're going to evaluate the function at -4, -2, 2, 6, and 7. That just means that we're going to plug in those numbers for x and solve for f of x or y. First, we'll substitute a -4 for x. So we have 7 times -4 divided by -4 minus 3. That gives us -28 divided by a -7. And -28 divided by -7 is a +4. So whenever we have a -4 for x, we have a +4 for y. Now we'll find f of -2. 7 times -2 is -14 divided by -2 minus 3, which is a -5, and that gives us a +14/5. So our value for f of x is 14/5. When we plug in a 2, we get 14 divided by -1, which gives us a -14. For f of 6, I have 7 times 6, which is 42, divided by 6 minus 3, which is 3. 42 divided by 3 is a +14. Lastly, we'll find f of 7, and this gives us 49 divided by 4, and that's as simplified as it can go. So f of 7 is 49/4. And these give us ordered pairs. So we have an ordered pair of -4, 4, -2, 14/5, 2, -14, 6, 14, and then 7, 49/4. And we can plot all of those ordered pairs on our graph. Our last step is to graph the rational function. We're going to take all the pieces that we previously found and select the graph that fits that criteria. So I have a y-intercept and x-intercept at 0, 0. If I look at graphs A and B, I can see that there are x and y-intercepts at 0, 0. C and D do not have those intercepts. Next, I want a vertical asymptote at x equals 3. That means I'm going to have a vertical line at +3. So here I have a vertical line at x equals 3. Here I have a vertical line at x equals -3. So I automatically know that B is not my choice. I can go ahead and look at A and make sure that I have a horizontal asymptote at y equals 7. So if I look at that vertical line, it should be going up 7 on the y-axis. And then I can further check to make sure that each of these points are on that blue graph, and they are. So that means my choice is A.